All right, page 112, adding with unlike denominators. Unlike, so when we said anytime we need to add or subtract with fractions, we need to make sure we had common denominators. When they say unlike, that means they are not common, and we need to get them to be common before we can do any adding or subtracting, but just adding in this case for today. And the process will remain the same when we subtract. It's just a matter of kind of getting a hang of what you're working with and how the numbers relate to each other. We use GCF to get fractions in the simplest form. We use LCM, least common multiple, to get common denominators. So if we were to have a 3/8 and we were to add that to a 5/6, probably want to get used to writing your problems out vertically with one fraction on top of the other. It's just much easier to work through it and get your common denominators all worked out. Now, I won't ask that you do a factor tree each time you need to find the LCM of these particular denominators. What you might want to do, though, is you've got two denominators up there that are different. You have an 8 and you have a 6. You might want to focus on the larger of the two to start off with. And you'll ask yourself, is 8 a multiple of 6? 6, 12. No. So you go to the next multiple of 8. What is the next multiple of 8? It goes 8, 16. Does 16 work for 6? Is 16 a multiple of 6? 6, 12, 18? No. Next multiple from 16 for 8. 24. Does 24 work for 6? Yes, it does. So I'm going to convert these both to 24ths. Okay. Question, Casimir? Yeah, with multiples, right. Okay. It's just easier that way to say, if we start with the larger one, it's much easier to find the common denominator first. So here we go. 8 to 24, we had to multiply by 3. 8 times 3 is 24. So up top, 3 times 3 would be 9. So on the bottom, 6 times what is 24? So 5 times 4 becomes 20. So now we're all set to go. 9 24ths plus 20 24ths become, can I leave my fraction that way? No, because it's improper. So how many times is 24 going to 29? How many would be left over? So 1 and 5, 24. Hello? Yep, I do. Sure. Just hold on. Mariah, come here. Go ahead and give me the number. 906 7125. Do you know that number? Okay, can you grab it? 906 7125. Okay, she'll call it right now. Yep. Mom wants to talk to you. Need to get on the phone. Okay, so we need common denominators of the multiples. So you did, if we use the 8 and we start thinking of the multiples of 8, is 8 a multiple of 6? No. 16, 24. We started listening through the multiples and we said, well, if I have the multiples of 6, I've got 12, 18. None of these are matching up. okay, until I get to 24. So that's why I use 24th, and I need to figure out how I got from 1 to the next. Okay, stick with it. We'll do some more. Okay, might not be a master on it the first time we see it, but it doesn't mean that we can't get it worked up. Oh, I do want to point something else out before someone else catches it and says, oh, well, how about this? So that was 3/8 and 5/6. Some of you maybe didn't catch 24 as your common denominator. Maybe you thought of something larger, like 48. How did you get 48? Yeah, sometimes people take 8 and 6. Sometimes they take those and they multiply them together. That is always a way to get a common multiple. It's always a way. Could it work with 48? Let's test it. 8 times what is 48? 6 times 3 is 18. 6 times 8 and 5 times 8. 18 plus 40. 58 or 48 into 58. 10 left. Can I simplify 10 and 48? It's the same. Is it the same? Yes. But if we don't, Edsel, if we don't use the smaller, if we use a common multiple but not the smallest, you will have to, I guarantee, you will always have to simplify. Always. Which is okay, if that's what you're comfortable with. Now, if I use the smallest, like here I use the 24th, it was the smallest, it was the least common multiple that they had. Does that mean I never have to simplify? No, I still have to simplify every once in a while, but more often than not, you know, it sure is better than using these larger numbers. So it can still be done, but not recommended. Okay, let's try another one. Let's go with let's go with 2/3 plus a 2/5. Again, let's focus on the larger denominator, which in this case is going to be the 5. So I start mentally going through my multiples of 5 and asking myself if those multiples work for 3. 5, does it work for 3? 10, does it work for 3? 15? There we go. So let's convert these to 15ths. Do you get that part? Okay. So now I have to compare and see, how did my denominator go from a 3 to a 15? Times 5. That's why I put this times 5 here. So whatever gets done to the bottom has to be done to the top. So 2 times 5 becomes, it's all, remember we made equivalent fractions, Casimir? Way back when we said you can use multiplication to make equivalent fractions. You can pick whatever number you want. In this case, I can't really pick whatever number I want. I have to kind of work with whatever was given. So 5 times what is 15? So 2 times 3 becomes 10 plus 6. 1 and 1/15. Questions? Casper. Which one? This one or this one? Because 15 goes into 16 once. And the 1 is up here is what's left over. It's like if I was setting this up. 15 goes into 16 once. How many were left over? The 1. Sure. That's where it comes from. Yes, ma'am. Well, yeah, I mean, essentially, it's all you're going to have to do. Well, let's work through a couple of mixed numbers. Sure, I'll give you one to try, and then we'll go from there. Okay? But yes, essentially, Kayla, this is it. And working with the estimation that we did earlier last week helps kind of lay the groundwork for what's happening here. So let's go 6 and 3/5 plus a 4 and 2/3. Okay, so 5 and 3, we had 5 and 3 before. We used 15. 5 times 3, 3 times 3 was what, Carlos? 3 times 3 is what? 3 times 5, 5 times 2, 19/15. 6 plus 4 is 10. Michaela? Simplest form? 4/15? Good stuff? I know you're at a 3 instead of a 4. Did you have the 19? Your subtraction was off. All right. You got 3 of them. But the process is still going to be the same. You're still going to focus on, are you going to focus on the 14, the 4, or the 2? 14. Give it a shot. Let's look at the 14. Is 14 a multiple of 4 and 2? No. Next multiple of 14 is a 28. Does 28 work for 4? Yeah, 4 times 7. It definitely works for 2 because it's even. So let's use 28. 14 times what is 28? 2. So 11 times 2 becomes 4 times 7 is 28. So 3 times 7. 2 times 14. Right. Good, Desi? All right, 2 and 1 is 3, and 7, and 2, 4, 5, 57 over 28. So how many times then, Tasnia? Twice. 2 of them give me 56. Take 56 away from 57. How many are left? Good, 1. 28. Okay. But you had the 22, 21, and 14? There we go. Have a seat. Why do we look at the larger one first? Just because sometimes that is your least common denominator. When I look at 18, I can say, does 18, is that a multiple of 9? Yes. So I can just keep it as 18. Okay? So here I'll have to convert and say 9 times 2 is 18. So 1 times 2 becomes 2. This is exactly the same. So I could go through the motion and say 18 times 1, 3 times 1 is 3. 2 plus 3 is 3 plus 0, and that's it. Okay. One more. 1/6, 2/5, 1/3. Okay. Between my 6, 5, and 3, let's work with the 6. Think of the multiples. If it is, the one thing you need to take into consideration when you have 5 as one of your denominators, the only multiples that are going to work for 5 is if they end in a 5 or a 0. So when you think of your 6s, 6, 12, 18, 24, 30, 30 works for 5. Does it work for 3? So that's what we're going to use. 6 times 5, 1 times 5. 5 times 6, 2 times 6. Times 10, times 10. Good. 5 plus 12 is 17, plus 10 is... Okay, good. And they both have 1 in common. 3. So 27 divided by 3 is... So you will have to simplify if it calls for it. Yes. 9/10. So when you re-added those, you got the 27. Anyone absent today? All here. Let's see.